Hello students, in this video we will discuss the hyperfine splitting and hydrogens. Okay, now we know the electron is the magnetic dipole is equal to mu e is equal to minus Ge and E divided by 2me. Okay, this is the mass of electrons and the spin of electrons, and here minus is due to the electron is negative charge particle. Okay, and similarly the proton, like the electrons, have a magnetic dipole because this is charged particle, is mu p is equal to Ge and E divided by 2 mp. Okay, this is the mass of protons and also with the spin of protons. Okay, and here the value of the Ge is exactly equal to 2 according to the Dirac theories. Okay, and here the value of the Gp, this is Gp, is equal to 5.59. Okay, this is the value of the Gp. Now we put here the value of the Ge, then we will get this 2 is cancelled to this 2, then we can write here directly is 2me and to Se. This is the value of the magnetic dipole for electrons. Okay, now classically the proton create a magnetic field which is seen by the electron is given by Sp is equal to mu naught divided by 4 phi r cube into 3 and mu phi dot r unit vector, and then r unit vector minus mu p and then plus 2 mu naught, this is the free space permeability, divided by 3 and mu p and then the delta functions. Okay, now the Hamiltonian of the electron and the proton magnetic field is called the hyperfine interactions. Okay, and which is given by H as per the hyperfines is equal to minus mu of electron dot p. This is the magnetic field of proton and this is the magnetic dipole of electrons. Okay, then we put here the value of the mu e and the magnetic field, then we will get the H f for the hyperfine splitting is equal to we put the value of the mu e is and minus plus minus and then minus E divided by me and Se. Okay, dot the magnetic field is mu naught divided by 4 pi r cube and then 3 mu p r unit factor minus mu p and plus and 2 mu naught divided by 3 and mu p and then the delta functions. Okay, okay. Then we multiply this term to first this term and then this term, then is equal to this minus is become and this minus become positive. Okay, then this is equal to, we take the constants here, then this is equal to mu naught and E divided by 4 pi r cube me, this constant and this constant, and then the Se, the spin of electrons, taught here, this is 3 into the, we put here the mu the magnetic dipole of protons, then this is Gp and E divided by 2mv and sp, the proton spins. Okay, then r unit vector and minus what the value of the mu p is gpe divided by 2mv and the spin of protons, then plus this term is multiplied to this term, then this is equal to 2 mu naught divided by 3, and this term is me and se, and then the we put the value of the mu p is gp dot here, gp and e divided by 2mp. Okay, and then the delta functions. Okay, now we simplify this term. Then first of all we take the constant here, then is equal to mu naught and g phi and e square. Okay, and then divide by 8 phi, here 2 is multiplied to this as 8 phi and mp me, the mass of electron, the mass of protons, and then this is se. Now we multiply this is into this term, then we will get is 3, and then this is sp r unit vector. These constants are take here. Okay, and then is unit vector r, but we multiply this term to this r, then this is equal to is se at r unit vector minus we take this commons. Okay, then and sp dot se. Okay, we multiply this term to this term also, and then plus this 2 is cancelled to this 2. Okay, then we can write this as mu naught and gp e square divided by 3 mv me. Okay, and then the spin of proton and the spin of electrons and the delta functions. Okay, now here we using the first order perturbation theory to find the first order energy correction to this. Okay, then the first order energy corrections is the sample is the expectations value of the 8 states, the good states. Okay, then we take the expectations of this value, this is h hat. Okay, we take the expectations of the HF, then this is the first order energy corrections. Okay, then is equal to this is constant, so we write here is mu naught gp e square divided by 8 phi mp me, and then this is this value. Okay, and then this is 3 and sp dot r unit vector and se and r unit vector minus sp and dot se. Okay, divide by r cube. Here we write r cubes. Okay, the r cube has remained here. Let us look here. This is r cube. Okay, then we can write here, this is r cube and the Hall expectations. Okay, and now this term is plus, this is constant mu naught gp e square divided by 3 mp me. Okay, these are constant, and then this is the sp dot se expectations value. Okay, and now this delta functions as, because the delta function is the wave functions of its origins, the modulus square. Okay, and then we can write here, this is the psi 0, this is the ground states. Okay, and its modulus square, this because this delta functions is the wave functions at the origins, this is the modulus square. Okay, then for the ground state, n is equal to 1 and l is equal to 0. Okay, now then this term is goes to 0. Okay, and only this term is remains for the ground states. Now then we can write here is the first order energy correction to the hyperfine structure is equal to mu naught and gp e square divided by 3 mp and me. Okay, and then the sp, the spin of proton and the spin of electrons, and the wave function at origins. Okay, then here we put the value of the psi at origins, and we already discussed in the chapter number 4 and the quantum mechanics of the derivatives. Okay, and then this is equal to as the psi 1 spin n is equal to 1, and this is 0 0. Okay, is mod square is equal to 1 over phi a cube. This is the value of. Okay, now we put here, then the E1 this is equal to mu naught and g phi and e square divided by 3 phi and mp me and a cube. Okay, and then this value as sp dot se. Okay, and this equations is depend upon on the coupling between the spin of the protons and the spin of electrons for ground states. Okay, for ground states, this is depend upon the spinning of electron and the spinning of protons. Okay, and which is called spin-spin coupling. This is like spin-spin coupling, the spin of electron and the spin of protons. Okay, then we find this value of the spin of electron and the spin of proton and the expectations value. Okay, now then we know the good state or the eigenvector of this total spins. Okay, then the total spin is equal to the spin of electrons plus the spin of protons. Okay, we squaring both sides, then this is S square and this is SE plus SP whole square. Okay, then the S square is equal to SE square plus SP square and then plus 2 SP dot SE. We can find this term. Okay, here we look here, we find this, then we can find this term, then this is equal to SV dot SE and we transfer this two term to this side is equal to S square minus SE square and minus SP square, and then divide by this 2 is 1/2. This is the value of this. Now we find its expectations value, then this is SP dot SE is equal to 1/2. Okay, and we know the S is equal to, or we can say the S square is equal to S and S plus 1 and H cut square, and similarly for the SE square and the SP square. Okay, then we take common the H cut square. Okay, then we write for S is S and S plus 1, then for electron, for the spin of electron is SE and SE plus 1 minus for protons SP and SP plus 1s. Okay, H cut square is common. Okay, then we put this value into this equations. Okay, then this is equal to EHF1, the first order energy correction to the hyperfine structure is mu naught and G phi E square divided by 3 phi M E N phi and A cube. Okay, then the value of this is H cut square divided by 2 N2 S and S plus 1 minus the SE and SE plus 1 minus SP and SP plus 1s. Okay, now we know the spin of the electron and the proton both have the same spin half. Then we can write here as the SE square is equal to SE and to SE plus 1 H cut square. Then we will put the value of the SE is half, the its spin is half, then this is half and this one is half plus half and H cut square. So this is equal to 3 divided by 4 H cut square, and similarly for protons. Okay, this is also equal to for the spin of protons. Okay, this two value. Okay, then we can put here this value. Okay, and then we can write here is EHF1 is equal to mu naught G E square divided by 3 phi M E M phi A cube, and then this value. Okay, this is equal to H cut square divided by 2. H cut square is take common here. Okay, then is S and S plus 1 minus 3 divided by 4 and minus 3 divided by 4. Okay, now we can simplify again, and this is equal to mu naught g e square divided by 3 pi m e m v and a cube. This is equal to h cut square divided by 2 and s into s plus 1 minus this is equal to minus 6 divided by 4. Okay, then we can go to the next stage. Okay, now here we write this equation again, and this is equal to the E HF1 is equal to mu naught and G phi E square divided by 3 phi and m e m v, this is m v, and a cube. Here we write again these equations. Okay, and then s and s plus 1. Okay, minus 6 divided by 4. Okay, now there are two states. The one is the singlet state. For the singlet state, the total spin is 0. Okay, then the s is equal to 0, then this is small s, then the s and s plus 1 is equal to 0. We put here the value of s 0, 0 plus 1, this is equal to 0, then the s square is equal to 0. Okay, for the singlet states though. And now for the triplet states, the total spin is once, the s is equal to once. Okay, then the s and s plus 1 is equal to 1 and 1 plus 1 is equal to 2. Okay, and h cut square also, here we write h cut square and h cut square and 2 h cut square. Okay, then we can write for these states, this is there are two possibility for the singlet state and the triplet states. Okay, then we can write these equations is the total spins can be either be the singlet or the triplet state. Now then we can write here is E and HF is equal to and here the mu naught, and put the value of the mu naught here, and then we can write these equations as like this is 4 GP and h cut 4 divided by 3 mv and me and c square and a4. Okay, and then there are two states for the singlet and for the triplet. Then we can write this in the two way. Okay, the first here we look for this and this side. Okay, to simplify this, then this is equal to h cut square divided by 2 and put the value of the for the singlet state is 0. This is 0 minus 6 divided by 4. Okay, then this is equal to h cut square divided by 2 and this 2 is cancelled to this. This is 3 divided by 2 and minus, and then this is equal to h cut square divided by and minus 3 divided by 4. Okay, and then this is for the singlet states. Okay, now here we write for the triplet state to simplify this. Then this is equal to h cut square divided by 2 and the H spin is 2. Okay, this is a S into S plus 1, this is this value. Okay, then this is 8 minus 6 divided by 4, and then this is equal to H cut square, and this is minus 2 plus 2 divided by 4, and this is 1/2, this is H cut square, and 1/4. Okay, then the H possibility is 1/4 plus for the triplet states. Okay, this is for the triplet case, and this is for the singlet. For the singlet, this is minus, we take common the H cut square, this is minus 3 divided by 4, and for the singlet states. Okay, then here the energy cap is delta E. Okay, is equal to 4G phi H cut 4 divided by 3 m phi me and C square A4. This is the energy gap between these two states. Is when we put the value of these constants on, then we will get 5.88 10 raised to the power minus 6 electrons, or this is the energy gap between the two states though. Okay, now we can draw here, use another color, is this one. This is the unthought of. Okay, this is the unthought of case, and when we apply this then the one state is here and the another state is here. This is the triplet states. Okay, and this one is the singlet, and for H the H spin, total spin is 0, and for this the H spin is equal to 1. Okay, and the difference between this two level or this two state is this delta E, is the this value is equal to this ones. Okay, this is the delta E between the two states though, between the triplet and the singlet states. Okay, then we can find the H frequency, as in we know the nu is equal to delta E divided by H cuts. Okay, and here we put the value of the delta E and the H cut. Okay, then we will get the frequency is like this ones. Okay, this is the frequency. Now we find the wavelengths, then we know the wavelength and the frequency is equal to the C. Okay, then we find that then this is equal to C divided by nu, and here we put the value of this 2, and the speed of light is 10 raised to the power 8 meter per second square per seconds, divide by, and this value, the value of nu is this one. Okay, then the H value is equal to 21 centimeters. Okay, this wavelength is small in the microwaves regions. Okay, microwaves. And this region, this wavelength. Okay, and this wavelength is can be found in the astronomy. Okay,